Okay, hello, welcome to my machine shop. Here is a vacuum cleaner that the cover broke on it. The hinge, it's a plastic cover with a plastic hinge, and this broke off. And here's the cover to it. And I was asked if I could try to fix this, maybe machine a new piece for it. So that's what I'm going to try to do. It's going to be a fun machining challenge. And we'll see how this works out. Okay, so now the first thing in order is to remove this broken hinge right here. As I'm not going to pry hard, but if I try to pry this right here, this hinge is one solid piece, and this is not going to spread apart. So the way this was built, it was built in place like that, in such a way that once you get it in, you can't get it back out, which makes sense. Now, I don't need the hinge itself. I just need to get this part out of here in one piece so I can glue it back onto the original here, temporary, so I have something to work with for getting dimensions and things like that. So what I'm going to do would be the best thing to do would be to just cut these pins as best I can to remove the rest of this hinge out of here in one piece. I think a good saw to use would be something like this. It has a nice thin blade to it. If I just get down in just where the pin is at and keep it to this side of the catch right there, so I don't cut that, I should be okay to cut this pin off. There we go. The hinge is, the one pin is cut off, and there's the hinge piece, and this is all intact here real nice. We'll set this to the side, and we'll glue this back on here in order to get the dimension of this here, how it goes on here. Okay, so I'll put a little super glue here on here, just to temporarily hold it in position. To hold that in position for myself here while I'm getting the measurements. And there it is. So we got a good temporary hold here now. And so now I can start taking measurements. Now I don't want to use this here super glue as a holding for this permanently, because this is eventually going to break off again, because it is still a weak point there. Even though it is super glued, it's nice and sturdy now, but constant use of that's going to end up breaking that back off again. So it needs to be made as one piece, and that's what this machining project is going to be about. Okay, I have some of this here commercial cutting board left over from another job I was doing, and this here is about the right thickness I need that will allow me to be able to machine everything, and it will encompass the thickness of the hinge as well. The only thing that it won't capture in thickness of this would be just that last part of the latch right here, and that's okay because I can always glue a piece back on there later on when I get everything machined to build that out. But everything else is thick enough to make this whole piece with. So what I'll do now is I'll cut this to a rough size on my bandsaw. Okay, there's the blank. To put that in my lathe, and let's get to work on it. Okay, let's set up a fixture here that I can put on my rotary table. Just using a piece of plywood and getting the center close to the center established. Okay, I'm going to measure center to center distance on the T-nuts here, about 5 1/4. And that would be 2 5/8 off of the center. Five-eighths. 5 1/8. Okay. Okay, these two sides here are the factory square edges, so I'll put them out front. Okay, so now I'm going to line the front edge up here in line with the x-axis table movement. So I will move this, and I'll check with my indicator here. And as much as it would be off, I will turn the rotary table. Right now we're only about a couple thousandths only. Now we're starting to get a little more. About 5 thousandths. So I'll turn the rotary table half that. About right there. Now, because I have a very small base here and extension arm here, I have to have this on an angle. But it's still going to serve the same purpose. All they're doing is checking for any kind of out of alignment of the rotary table with the straight edge here going across. And right now I'm pretty much back on 0 again. So I would say that's good. I'm going to lock the table right there. So what I'm doing is I'm locking the rotary table. Because all I was doing was getting the rotary table lined up with the x-axis movement. And so I only had to move the rotary table itself, the rotation of it, only a few degrees, because I was only about 5 thousandths of an inch off from here to here. Okay, so we'll get that one more. Now I got it locked up. I'll just give it one more check here. Okay, right there is 0. Right there is 0. Come across. Got a little bit of deflection there because of some irregularity there, but if this comes back to 0 here, then we're good. And it's coming back to 0. There it is, back to 0. It only went off about 5 thousandths in this one small area right here, so that shows it's just a little bit of a surface deflection. But from here to here, it is actually pretty close to being straight with the axis of the table. Okay, so now what I'm going to do is I'm going to look for that there, the angle on the rotary table, and I'm going to record that number as 181.5 degrees, and I'll mark that down. Okay, so now what I did was I jumped ahead of myself. I should have, when I had the rotary table in the center of the spindle, I should have made my hole in here, my reference hole in here. So what I got to do now is I have to take the workpiece back off again and get the center of the rotary table back on the x-axis, back under the spindle center, and then put the workpiece back on there. Now since I didn't move the y-axis, all I gotta do is just move the x over until I'm on line there. Bring the z down here. Alright. Okay, that's in line there now. Okay, so now with the table locked in position both on the X and Y axes and the rotary table is locked in position, I am now fully under the spindle center. So now I'll make a reference hole here with the 1/4 inch bit. Okay, now with everything still locked in position, I will mark out the edges. This will be the hinge side, so I'll mark hinge on here. The front, I got marked reference. This side here will be the lock side, mark lock. I'll mark hinge here on the fixture also, so I know which way that goes. On there. Okay, now with the workpiece securely fixed on the fixture here, I'm going to get a height of the workpiece itself, preliminary. Catch that edge if I can. Right there. Okay. 920 thousandths. So I have that written down here. My reference height, 920 thousandths. Alright, so the first thing to machine that would be a critical measurement would be the outside, the outside diameter here, and the inside diameter here, because that's where a lip on the machine itself will fit down inside this. So this here distance from here, inside here to inside here, and outside to outside is the critical measurements. So we'll get the outside, and the reason why the outside is critical is because the outside also encompasses the edge of the hinge and the latch at the same time. And so in order for that to work in conjunction with the diameter has to be pretty well spot on. So what I'm going to get to here is get this diameter, and it looks like about 3.915. So I'm going to round it off to the outside diameter to be around 3.92 inches. Okay, so my finished diameter is 3.92. My bit diameter is 0.25. Half of that 3.92 is 1.96. And then I subtract half of my bit diameter, which gives me 1.835. So I need to move my x-axis 1.835. Now what I'm going to do is I'm going to move that 1.735. I'm going to keep that 100,000ths of an inch short. That way I can see what the actual dimension comes out to, and then I'll know how much the bit is deflecting, and then I can accommodate for that. Okay, I'm machining some small increments and sneaking up on the cut. I'm about 3.9 or 3.8, 3.89. I need to go 3.92. About 30 thousandths to go yet. Alrighty, I got another 5 thou to go. 2, 4, about right there. See how that works. Let's see what we got here now. I need about 3.92 is what I need. And 15, about 18. Okay, I got another 5 to go yet. That's probably some tool deflection too. You know, that's plastic. It's probably some tool deflection doing that. Let's see what we got here now. Oh yeah, there it is. 3.92. That's what we're looking for. Okay, see now I want to establish the depth of cut. Okay, the high point is on the rim, and it's about 3.37, 370 thousandths off of the bottom. Okay, so the workpiece height is 0.920, and it's 0.920, the height that way. from here to here, 0.37 inches. So 0.92 minus 0.37, 0.55. So we need to come down a depth of 0.55 inches. And half an inch we have to come down every half inch, 550 thousandths. Okay, we got 35 thousandths on that. Okay, so 0.55 minus 0.035, 515 thou. Need to come down 515 thou. Okay. 100, 200, 300, 400, 500, 10, 515 thou. 15, 1, 2, 3, 4, and 5. Okay, I'll dip it down about 50 at a time here for starters. 50 thou. Once I get inside the hole there, right there. So I'll come down now 50 here. Here we go. Okay, so now I can machine all this here out now, down to that depth. I'll move the x-axis now about 100 thou at a time. And I'll keep on machining this now right until I get across here. Alrighty, I got all that machined on the inside here. And what that is the full outside diameter from here to here, is what this is from here to here. The next critical measurement now is to get the measurement in the side of the groove here from this end to that end there, the diameter of that groove. That's coming up next. Okay, so the next critical measurement is right here inside the slot here, because this has to fit the machine itself, and it looks like 3.8 inches across from the inside here to inside here of the rim, and we can't go any smaller than that. 3.8 should work good for that. Alrighty, the diameter is 3.8. My bit that I'm using is 0.125, an 1/8 inch bit, so I have to get half of 3.8 first. 3.8 divided by 2. Okay, so that of course would be 1.9. So this is 1.9 inches. Now that puts my bit on center, so I have to subtract half of 0.125, which is 63 thousandths. So 1.9 minus 0.063 equals 1.837. 1.837. And that would be the x-axis traverse. So I need to traverse the x-axis 1.837. Okay, so I'll traverse the x-axis now. 1.837. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 1.8, 10, 20, 30, 35, 36, 37. Lock it in position, and we'll see how that works. As you can see, the distance between the bit and the edge of the workpiece here, that has to be pretty close to the rim of this right here. In other words, this rim right here, the thickness of this rim right here is roughly going to be, that's about 65 thou, is roughly going to be the distance between the bit and the edge of the workpiece. Okay, so that's pretty close to the thickness here, so it's 58 thou. And that's roughly anywhere between 55 and 60 thou is the thickness of this rim right here. Actually get a good measurement here. It's about a 55 thou. This is 58 thou on this. It's a little bit thicker, but it's about 3 thou thicker. But we're going to use this just to feel in here. Let's see what we got. So if I take this, it's hard to see it, but it does seem like that is going to be, see, I'm working with a round. It does look like that's about 60-some thou distance in between, and that's what we're looking for. So alright, let's go ahead and see how that works. Yeah, I think we're there. 3.805. 3-inch, 805 thou. So we need 3.8. You see that? So I believe we got what we needed at 3.805. So I think we'll be good with that. So now we're going to establish the depth of cut, and that would be to the top here. The reference would be to the rim here, because that's what we have reference right now. Take this here and we'll look at this here dimension right here now, the depth of cut for this groove. Okay, we're about 185 thou, roughly. That'd be the depth of cut for the groove that we're working on now. Just doing a cleanup pass here now. down to full depth right now. And then we'll check it for the diameter to see if we got the diameter right. Okay, we'll check it for the diameter now and see if we have a 3.8 is what we're looking for the diameter, as well as 180 some on the depth. Okay, here we go. Let's see what we got here now. Okay, 3.810. We got what we need. 3.810. We're good. We can't be any shorter than 3.8, or else it won't fit. So 3.810 means that we got plenty of room here now for that to fit in there. Okay, again, taking a measurement of the original here, we're at about 3.805. 7, so we're within range. On the original here, we're about 3.805, so we're about 5 thousandths larger, which is good. It's better to be larger than too small. So we're within good range. Okay, so far the two most critical dimensions would be the outside diameter here. Would be this outside diameter. Then we have a lip that steps down, and the depth of cut here, and the outside or the inside diameter from the lip here over to the other side. So this outside diameter here and this outside diameter here are the two critical measurements to make sure that fits the machine that this caps onto. The rest now, we take this down and come across and do our other machining profiles. That's being shown here. We've got a little bit of a divot right here, and this goes down here, and things like that. That's coming up next. Okay, so the next thing now would be to bring everything that's on the inside here from this here groove all the way in now to the proper height now. All of this is the same height until we get into the center here, and then that dips down just a little bit. So let's go ahead and get this measurement at the rim here, and all this measurement here. Okay, so the measurement, I'm trying to hold the camera and trying to do this at the same time, so I'm going to have to put the camera. Okay, let's try that. Okay, that's 348. Here's the outside rim, and here's the inside rim. Okay, so it looks like the inside rim right here is lower than the outside rim, and that's about the same height as this area here is. That's about 0.348. So we'll adjust our z-axis on the mill and bring that down. Okay, so I'm going to swap out the 1/8 inch bit for a larger bit, 7/16 inch bit, so that we can hog out more material that way. Okay, so now I can find out how much I have to drop the bit down from the outside rim height. That's at 0.365, the outside rim, and this is at 0.48. That's 2. That's 5, 10, 12. Okay, in overall dimension here, using this is about 0.368, the outside rim, and the inside is 0.348, so about 20 thousandths of an inch in depth on the z-axis would work for that. Okay, averaging out the height of the rim is roughly about 0.368. The inside here is 0.348. So 20 thousandths depth of cut on the z-axis should work for that. Okay, so you said the filler gauge here at about thousandths of an inch, 1.5 thou, right there. And now we'll drop that to about 20 thousandths of an inch on the z-axis. Take it from there. Okay, before we go any further, there is a step down from here to here. I milled all this out from here all the way to here, and this is still the original right in the center here. It's just so I can get a quick check here of the height difference and see how close we are to our 20 thou difference here. Let's see, get here. There we go. Let's see how much we got here. Okay, there we go. About 20 thou. Continue on. Okay, so now I want to get the center, the workpiece center of the spindle again, so I'll take out this here bit and put the 1/4 inch bit back in again. Lower that and get our table movement over again on the x-axis to get it back into the center of the spindle. Go this direction a bit now. Again, process of bonus. That looks like that's the center right there. Okay, so I think the next thing in order now would be to machine all of this to depth right here and get this here inner ring here, the edge of that ring established. And now what I need to do is get the diameter from the inside here now to here, and that would take care of the inner ring. So we go like that. Alright, that's about to get in the light here. Right there. So that looks like 3.5, 3.49, 3.5, about 3.5 inches. I'll have to take a little better measurement of that, but around 3.5 inches should do that. Yeah, doing a better, holding this better and getting it closer on here. It does show that to be about 3.5. And I get that right on center like that. Right there it is, 3.5 inches for that diameter. Alrighty, so my diameter to get is 3.5. That means half of that is 1.75. I'll have to check that then. 1.75, and then my bit diameter is 1/4 inch. It's 0.25. Half of that is 0.125. Alright, so I need to move this over. Okay, so if I move my spindle over to 1.75, that puts the spindle on center where I want it at. So to bring the edge of my bit over, I need to move over half the distance of the 1/4 inch bit, which is 0.125. So we take 1.75 and subtract 0.125, and that's 1.625. So I need to, x-axis has to move 1.625 to establish the ring that we're looking for right here. Let's move this 1.625. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. That's 1.6. 10, 20, 25. Now let's see what we have at. When we bring the bit down. When that bit comes down, how much of a edge do I leave here? Let's check and see. That looks pretty good there, but I think I'm going to snake up on the cut because I don't want to go directly to there. So I'm going to come back out this way about 50 thou and then work my way over to it. Okay, so I moved my x-axis 50 thou out of there, so I should have close to about 50 thousandths of an inch before I get to the edge of this here, which means is that before I get to the stop point, I should say. So when I bring this here down, I should be the 50 thousandths away from the final cut. And let's see what we got. Okay, so now we want to go for depth, the depth of the cut. And right now we have this surface right here is our reference now, because that's what we have established in the cutting. We have it down to this height here. So we're going to take a measurement in relation to this. We'll take a measurement to the top of this, and then we'll take a measurement down to here. Now I cannot get my gauge down in here where I need to get it at. So I have to use a little bit of a gauge block here. So we'll just use something like this here that will fit down inside. So we'll take a measurement here on top using this here gauge. We'll get this here measurement. And that is 0.925. 0.925. Let me write that down. 0.925. And then we'll put this down inside here where it fits comfortably there, and take that measurement. And we are at 0.675. Write that down. 0.675. And get the difference of that now. Okay, so that would be a depth of cut of about 1/4 inch, 250 thou. So there's 250 thou difference between the bottom of this and this surface right here. Okay, so I took a filler gauge and got that reference to there. So I'm going to take it down now 250 thou on the z-axis. That's 100, 200, and 50 thou. It's 250 thou right now. So now I'll set that, my gauge, bring that up to 150, 50, 100, 200, come down about 50, and start cutting. Okay, so I have all that milled out to the final depth all the way around, and we went around 3.5. So let's see how close we are here on getting the diameter. We're looking for about 3.5. Let's see how close we are to getting that diameter. Remember, I did set that back 50 thou, so let's see what we got here. Okay, I'm at 3.42. 3.42. Yep, 3.42. So that's about 80 thou to go yet. I'm going to take a look at that and see if that really needs to go that thin. Meanwhile, I'm going to continue machining this back this way to get the rest of that machined out where it needs to be. Okay, so now when I back that up, that 50 thou on the table movement, that actually brought the diameter in by twice that. So that's why I'm close to 100 thou, actually around 80 thou. But that's the reason why I'm larger, or I should say that's much more smaller than 50 thou, is because of the diameter being twice. Now what I'm going to do is I'm going to see if I can get a thickness measurement of this here rim and see how close that is. Because I need to take about 40 thou off of the thickness of the rim itself now to approach that 3.5, because I remember I'm 80 thousandths out on the diameter, so that means I need to take 40 thousandths off the table movement, so that I double that would be that 80 thou. Can I afford to take 40 thou off that? Let's take a measurement here with the dividers here and see how close I can get this to give me a thickness measurement here. That's pretty close right there. Let's give that a check. So I'll get my magnifying glass here, and we'll just see where we are here on the 64ths of an inch. So I can get you on the thing here, screen. And yeah, there you go. I'm looking at my magnifying glass. I'm trying to look at the camera. What I can't do is I need to look at the magnifying glass first. I'll be back. Okay, so I'm close to about 3/64. 3 divided by 64. That's 46 thou. I need to take 40 thousandths of an inch off. So there's only 6 thousandths, so that's not going to be good. So I think I'm just going to leave it at that thickness. Let's see what this is right here on the thickness here of the original piece. Let's see how close they are on theirs. Okay, the screen here. Let me see here. About right there. And let me check that now. I'll be back. Okay, so theirs is 2/64. Okay, theirs is 31 thousandths. Theirs is a 32nd of an inch. So that's a 32nd of an inch on this. I'm only a 64th of an inch wider than that there ridge. So I think that's going to be okay. So I'm not going to be concerned about that. I think I'm just going to leave that right where it's at and just take it from there and just go with that. Okay, so the next thing now would be to find out roughly how much this comes over. This is mostly aesthetics now. This is not so much functional. So I'll just see how far from here to this here drop down is right here, and then machine that out as well. And then come back up here and machine this divot out, and then the profiles on the inside here would be complete. So let's go ahead and get this part done next. Alrighty, so let's just get a quick reference here. Off of here to here roughly. And we'll call about like that, looks good. And that distance is, okay, it's about 410 thou. Okay, since my bit is 250, I just need to move the table that way now about 150, and that would give me about a 400 thousandths of an inch width of cut. So let's go ahead and move that table now 150. 150 thou. Bring this down. And we'll take it to the full depth of cut. Right there, and there we go. I should take care of that part. Okay, so that part's done, and the last part to do would be to do this little divot right here in the middle, and that is a little bit critical in measurement because the filter, the vacuum, actually fits down inside here a little bit, and we don't want that to bump that, and it needs to fit pretty close to the diameter across here too, so as to have a proper fitting. So that will be next, and that will be in the middle here. So let's go ahead and get that part set up. Alrighty, let's get this diameter here. Looks like it's going to be right there. And that's about 880. 875 would be 7/8. So I'm going to say that's probably 7/8. Yeah, I'm going to say it's, oops, I'm going to say it's probably 7/8. Should be 875. Very, very small. That's why it's hard to hold that on there where it needs to be. Actually, I better take my time and look at this here. I'm going to come back off camera and look at this here. Yeah, that diameter is 875. Right there, 7/8. Alrighty, so this diameter is 875, and that is 7/8, so 7/16 is half of that. My bit is 1/4 inch. Half of that is 0.125. So the table movement, 7 divided by 16 minus 0.125. Okay, 312. 312, 313, 312 x-axis movement. 312 thou. Okay, 312, 100, 200, 310, 11, and 12. 312 thou. Now I need to get the height, the Z height on this. Okay, again, I can't get my gauge downside there, so I'll just use this here again. This will be, oh, I can't because this is going to catch in that middle right there. Alright, next best thing, we'll use our gauge here. We'll use this gauge, and again this will be referenced off at the middle here. About 45 thou. Okay, a good check on that showed about 35 thou, so I'll make about 40 thou to ensure that I get the depth I need. Okay, here we go. Set my gauge here. I'm down 40 thou. Here's 40 thou, set my depth stop, and let's go for it. check that diameter now real quick. The gauge was getting in the way of the thing here. Okay, 880 thou, so we're definitely got our 7/8, 75, yeah, there they go. Okay. My calipers were hitting the edge here and I couldn't get a good measurement, so I'm going to use these cheap inside calipers. Just for a transfer here, just to see what we got here. Just to see how close we are. See about right there. Let's see how close we are now. About 860. Yeah, I'm going to take that a little bit more. Okay, now our 15 thou. Actually, these are pretty stiff to work with, so I couldn't get a really good transfer. So I went back to using my big calipers here that can reach down further, and it is about 870 thou, almost 875, so we're very close there, so I think that's going to take care of it right there. So just to be on the safe side, I think I'll take another 5, not quite 10 thou off, so here's, I'll go this way here, 2, 4, 6, about 8 thou we'll take off the diameter, see how that works. Because that plastic does want to bend around too, at this very light depth of cut. As long as it's in range of it, even within 10,000 should be okay. Let's see what we got here, how close we are. There we go, 880, that's where I want it, that's good. I'm satisfied with that. So, okay, so now I'll just bring this in and clean out that middle. Okay, so I decided that I'm not going to do any kind of a chamfer here like it shows here. There's no need for that chamfer. That's all just part of the way this was made for processing. So what I did was I just took that dimension and I just took this down flat down to here and just let it go at that there. The main measurements are the groove here. That's the main measurement, and the outside. That's the main critical measurements. Everything else is just part of the process of how they make their lids. But this will work just fine. Okay, so now the next procedure in this becomes a little bit more precise now. I need to get the rotary table back in line here, the table axis and the x-axis again. Our reference degrees mark, we had that written down in the beginning. Once I get that there, I need to get this thing back on center here, where I need to be. And then we're going to start working on the hinge, cutting the hinge and the lock tab over here, and do that profiling, and then cutting off this rim right here all the way around. And that's going to be very, very precise there, because that's going to be involving the very small rim thickness here that needs to be accounted for and things. And so now we're going to start getting some pretty well precision work that's going to be involved in here now, and that'll be coming up next. Okay, so now the width of the hinge is 950 thou. Okay, so the first thing I'm going to do is give myself a center line reference. Okay, so now I have that established, a center line for reference. Now I can start moving my table over to get my bit to the side of the tab for the hinge bracket. Okay, so half of that hinge bracket, the hinge bracket itself is 950 thou. Half of that would be 475 thou. And then I have to come over, and that would take my center of my bit spindle on the edge of that. So then I need to take half of that 125 thousandths bit I have diameter, which is 63 thousandths, add that onto here, and that would be how much I move my y-axis over. So 0.475 plus 0.063 means I have to move my y-axis 538 thousandths. 100, 200, 300, 400, 500, and 35, 36, 37, and 38. 538 thou on the y-axis, which puts the bit over here, and that will cut out the top side of the hinge profile. Now the next thing I have to do is I have to bring that bit down to the height of this outside rim, because that's where the hinge meets the workpiece right here on the outside rim. So I have to get that there depth. So I bring this over to here, and I'll use my little gauge here, and that'll get my outside rim to the top of this, so I know how far down to take my bit. Okay, I'm touching the outside rim, and that shows me right there the depth of cut. I'll use this to transfer it. Okay, outside rim, come down there. Right there. That's the depth of cut right there. Here's a good view of it from the depth gauge. Right there is the outside rim. Here's the first rim, and here's the outside rim that we have to machine to. And that's what I need to machine the depth to right there. And that depth of cut is down to there, which is 570. 570. 570 thou from the top of the workpiece. Actually, it's about 575 thou. Okay, so now I'll touch off right here with the it's about a 1.5 thou gauge. About right there. Come up a little bit. Right there it is. And so now we'll drop that 575 thou on the gauge, which is right over here. There's the gauge. We'll set that to 0. Split the 0. Set that up so I have enough to work with here. There it goes. 0. This is out of the way. Here we go. 100, 200, 300, 400, 500, 50, 60, 70, 5. And then we'll set the depth stop. Bring it back up. 75, 1, 2, 3, 4, and 5. And we'll set it for about 10 thousandths deep for the first cut. Okay, so now I machined that one side right here, and that puts my 1/8 inch bit on the left side of the bit on this side here. Now I need to move, now I'm actually going this way here, y-axis. Now I need to move my y-axis so that from here to here is 950 thou. Now to get the other end of the bit, the other diameter on this side, over on this edge here, I have to go to 950, which is the width of the hinge, plus an additional 0.125, which is the full diameter of the bit itself. And that comes out to 1 inch 75 thousandths. So I have to move my y-axis now in the other direction 1 inch 75 thousandths. And that will put my bit then on the edge of the bit on the other side for the machining. Okay, we're at 950 thou. Okay, so now my bit is down here. I did the cut. So now to get my bit back in the center of the spindle, back in the center of the workpiece, I need to move half the distance or half the diameter of the 1/8 inch bit, which is 63 thousandths. That would put me on the edge of the workpiece, and then additional 475 thousandths, which is half the diameter of the workpiece, or the hinge itself over to here. So it would be, again, we would have to move the y-axis back again, our 538 thousandths. Now I'll do the same procedure again, repeat it for the locking tab, and I'll do that off camera. Okay, that takes care of the hinge and the locking tab. And there we are, 800 thou. Looking good. Okay, so the next step is to get the height of the hinge. And that's from the bottom of the workpiece. And that's 670 thousandths from the bottom of the workpiece. Now re-establishing again the height of the workpiece from the bottom of the fixture again. I know we did this in the beginning, but we're going to just do this again to verify. Okay, so I am back on center now with my spindle, back on center of the workpiece. I have my height established for how far the hinge is from the fixture bottom, which is the bottom of the workpiece, and I have to come down from the top of the workpiece down 250 thousandths, and that would give me the height of the hinge. What I'm going to do is I'm going to machine that depth all the way around, and I'm going to do a stop cut on the tab here because the tab is full height. So I'll machine the height of the hinge all the way across here and stop here, then come on this side and do the same thing. Once I get that established, then I will rework the height to get me down to the next height, coming down to the rim here. Now I changed my bit back out to the 1/4 inch diameter bit, so I can hog up more material. Okay, there we go. Now what I'll do is I will unlock my rotary table, because I had it locked before, and I'm going to rotate the rotary table now until the edge of the bit is right on the edge of the workpiece here, on this edge right here, so that when I'm on the edge of this, when I come down to full depth, I'll be taking it right to the top of this outer edge right here that we're working to. Okay, so the first thing to do is to set it to the drop the z-axis 250 thou, 100, 250. Set my depth stop. Bring it back up 50, 1, 2. Bring the x-axis over now until my bit is right on the edge. Make sure I'm clearing the hinge, this here slot here, because I want to take all this out and stop right here. No, I'm sorry. I want to take the whole hinge completely off, down to that depth. So I do want to machine all the way around and stop at the tab. You'll see what I'm talking about. So let's go ahead and go to the tab first here, and we'll start. This will be our start cut. So I'll take it to where the locking tab is at. Make sure I'm clearing the nut. Yes. I'm right on the edge of my workpiece here, on the edge here, and we'll stop it right there. And that's where we're going to start doing the cutting. I'll go down about 50 thou, maybe 100. Go down 100. I'll lock my x-axis and begin rotating the rotary table, going past all this and stopping on this side over here. Because we're going to get this down to the height that the hinge has to be taken down to. Stopping here at the other side. Coming down another 50 thou. Another 100 thou, make it about 100 thou. And then go back. And I'll repeat this process until I get down to the height of the hinge. Okay, so I have it all the way down to the height it needs to be, and since I am free to move the x-axis, I can now move that out through this direction here and take off just this area here where the hinge is located. Oops, I want to lock my rotary table though first. Take it this way here, lock the rotary table, and take it out now, because this is all part of the hinge being cut out. And I'll keep on doing this until I get down to this side here. I'll rotate the rotary table a little bit now. I don't want to move the y-axis, so I'm rotating the rotary table instead. And take another cut. Rotate the rotary table, take another cut until I get down to here. Okay, so now in machining, when you're trying to duplicate a workpiece, you study the workpiece and you study its function, and you find out what parts of the workpiece are related to each other and what parts are redundant. What that means is, what is more important in the function of this lid? Is it the height of the hinge with respect to the bottom of the workpiece? That's one reference. But I think more importantly, studying this workpiece, it looks as though that the height of the hinge should be referenced to the outside edge here. The reason why I say that is because this outside rim right here is also going to be fitting onto the machine itself. And that machine that this is fitting onto is machined to fit the hinge with respect to where this closes on the machine. So the bottom of the workpiece is not so much a reference in that respect, but rather the reference should be the height of the hinge with respect to the height of the outside perimeter of the rim here. And so that's what I'm going to take a measurement on. As I took a measurement here, we have 670 thou to the top of the hinge. As I come down here, we have 370 thou to the rim. So that's a difference of 300 thousandths from the top of the hinge to the rim. So what I'm going to do is I'm going to take a measurement now on my workpiece. I'm going to go from the top of the hinge, which is right here, down to the top of the outside rim, and then transfer that measurement over and see what we have. So as I set this on here, get that locked in position, and I bring this over, I find out that I am 325 thousandths, which means is that my hinge is 25 thousandths higher than what's showing here, which is within range. So I'm okay with that. So now we have that referenced out. I can now start working on bringing everything down now between the hinge and the latch lock mechanism here, all the way down to the height of this outside rim now. And that, once we get that established, then we can move on to the next step. Okay, so that half there is machined down to full depth. It's now time to do this side here now to full depth. Okay, all the machining is machined down to depth now. So what I'll do now is I'll just advance the x-axis, move it forward a little bit, and clean out some more of this here back here now, just to give myself some clearance for the bit holder when I put the 1/8 inch bit back in, so I have some clearance to work with. Looking at this original piece here now, we see that the outside rim is about 60 to 70 thousandths in thickness, and that outside rim rides along the inside of the hinge and the latch. And so if I put my 1/8 inch bit, the edge of it right on the edge of the hinge side here, that should give me the reveal I need here on that outside rim. What I'll do is I'll keep this bit back a little bit further than that, just to see how that looks going around there first, and then work my way into that final dimension for the width of the rim. Okay, we're at 60 thousandths. Okay, so the whole outside perimeter is machined down all the way down to the wooden fixture. So all I gotta do now is just machine out now the hinge and the latch side. We'll put the rotary back on center again and get that, and then machine that out of there, and the whole thing should come right out. Okay, so now I do need to move the y-axis in order to get this to the edge of the hinge and the latch. If I get to the edge now, I can just machine it straight out. I'm just going to eyeball that up to get right near that. Straight out. Okay, so now I do have to machine down all this part here for the hinge and the latch and things like that, but we can check the machine itself here, the vacuum cleaner itself, and see how this lid fits on, because even though it's not going to fit on because of the hinge has to be cut out in order to be able to fit in behind here, I can still just turn it around, because all I want to do is I just want to check and see how this diameters here fit the rim here of the machine. So here we go. We'll just set it on here like this, and there we go. Look at that, nice and flush all the way around, like it. And it stays on up by itself. And let's see if we get any suction. Yep. Yes, sir. Got good suction. And you can see, got nice seal all the way around. So I would say that's going to work good. And I would say that's a good machine for the inside on the rotary table to get that to fit just properly. Nice snug fit. Not too tight, not too loose. We have enough taken out in the middle here to accommodate for this right here and everything. So I would say this is a very successful machining on the rotary table. Next up now will be start machining for the hinge and the latch as well. And that will be coming up next on the milling machine. Okay, so the next thing now will be to find out where the pin height is at. That will be the pin right here that pivots on the hinge, and we'll again take that with relation to the outside rim here, since they're the two important reference points to work with. Okay, through a magnifying glass I found the center of the pin at this height here on the original piece, and that's showing 555 thou to the center of the pin from the bottom. Now both of these measurements are being taken off the reference of the on the workpiece here for this piece here. I'm now going to take a reference measurement here now to the rim, again referencing off of the bottom here, and that gives me 370. Okay, so the rim is 370 from here, and the center of the pin is 555 thou from the same reference. So we'll find a difference in that, and then we'll know the difference between the rim height and the center of the pin height. Okay, so that difference is 185 thousandths from the center of the pin to the top of the outside rim. Okay, so now I take my workpiece and I set mine to the rim, and that too is shown at 370 thou. So all I gotta do now is raise it up 185 thou to 555 thou, and then mark the mark right here, because this is all pretty much referenced the same as the original. Okay. Okay, so there will be the center line in height from the bottom here, or I should say from the reference from the top of the rim here to the line is the center line for the pin height. Now the next measurement I have to make is the distance from the center of the pin, here to the outside edge of the rim itself now. Now I have to get that lateral distance now back. Okay, using my scale, it appears to be about 1/8 of an inch back, the center of the pin to the outside of the rim here, measuring back. Okay, so marking back now that 1/8 of an inch to the center. I have my lines established there to do the drilling. Now I got to find out what diameter of pin I need to use. Okay, measuring that comes out to be an 1/8 inch diameter pin. So I have a hole marked here now. I have it marked where the hole will be. And so we'll go ahead and drill that now for an 1/8 inch pin. Okay, so here's the setup on my angle block. In order to get this as close as I can to horizontal and vertical for the drilling down, I have that reference mark here that I did during the machining process to get the center of the workpiece right here. So I set up my gauge blocks here and I put a parallel up here to line that up with that line right there that indicates being a horizontal plane. Now I know then that that is horizontal. That means that this is now square. And now I'm reaming it now to the 1/8 inch diameter. And now an oversized reamer by 1/1000th of an inch. It's a 0.126. Okay, there was the hole drilled through. Right there. Alrighty, I took it to my bandsaw out in my wood shop there, and I cut that to that size there, so that will fit inside. I still got to do a little profiling down through here a little bit, and then got to do the latch side too as well. Let's see how this fits. Alrighty, let's see how this fits now temporarily. I'll just use a reamer. I can't shut it all the way yet because I have to make the latch yet. I have to put that there slot in there so that it will fit on there. But I think that's going to work okay. That's holding good. Okay, good. Next thing now will be to work on the latch itself right here. Put that hole in there for the latch. That's coming up next. Okay, let's go ahead and put this together now. What I did was I tapped this with 6 32 screws. I didn't have to use the tap, I just used the screws themselves. and I have some plastic hardware here, 632 screws, and I cut them short enough to work in this. And so what we do is this will slide over here onto the hinge section here. This will snap down over there like that. Make sure it's nice and tight there. Put the screw in like this. Just enough so it doesn't break the head off. Okay, and there it stops. Right there. Same thing on the other side here. Again, just so far until it stops. Okay, right there. Alright, let's see how it opens. Okay, good. It's just nice on the nice there. Let's go ahead and put the rest of it together here now. So this goes on here like this. Slide on there. It snaps in. Slides on here like this. Snaps in like that. Okay, let's see how it goes for suction now. Now I'm going to open the lid here and see how the suction is. There's no suction at all. The lid open. So I'll now put the lid on, and then we have all kinds of suction. So it means is that the lid is fitting properly. Okay, so there's the job done. Got a little bit of cleanup to do, some filing and stuff like that, some cleanup work, get rid of the rough edges and stuff. But that was a fun machining project, and very successful because it does work properly. And I enjoy doing that there. Thanks for letting me share this. Okay, have fun in the shop. Bye.